functions. So we've already done sine and cosine. Now what we're going to do is we're going to look at tangent, cotangent, secant, and cosecant. And so first of all, let's review. Sine and cosine, remember they were buddies. What period did they have? Or what was their period in the graph?
2 pi.
2 pi. Secant and cosecant are also going to have a period of 2 pi. Tangent and cotangent, on the other hand, are just going to have a period of pi. So they're going to be kind of the odd people out. So today what we're going to do is we're going to focus on how you graph these four. Okay, so first of all, I need you to look at your blue sheet for me. And we're looking in the tangent column. I want you to tell me where in the tangent column is tangent undefined. And I'm looking for radians. Pi over 2, where else? Pi over 2 and 3 pi over 2. Nice job, those are exactly correct. Okay, so I want you to think about if I was going to plot on a graph something that's undefined. How would I do that? A straight line? What? So when we think about it, if something's undefined, that means it has no value, right? I mean, it's not a point on the graph. And so what we're going to do is we're going to figure out how we're going to graph this. So let's go ahead and look at how we're going to graph tangent. Now, if you remember, it had some weird things happen at pi over 2 and 3 pi over 2. It was actually undefined at those values. Do you remember what we called those dashed lines? Asymptotes. Okay, remember those dashed lines were like invisible boundaries. They were like electric fences. Remember, our graphs touched them. They got really, really close, but they never actually touched them. Okay, and so whenever we have something that's undefined in tangent, or in cotangent, or in secant, cosecant, we're going to use an asymptote. Okay, so we're going to go and put dashed lines, and believe it or not, we actually have another one at pi over 2. Okay, I'm going to go ahead and get out of the, let's move that up a little bit, there we go. Okay, so now let's look at your blue sheet again. At 0, what was the value of tangent? 0, okay? So you told me that pi over 2 was 90, so let's just pick a value in between 0 and 90. Let's pick 30. At 30, what was the value of tangent? Root 3 over 3. What is that as a decimal? Calculate. You gotta calculate. Root 3 divided by 3. Okay, so 0.5. So 30 would be about a third of the way there, and it'd be about 0.5. Let's look at 45. That's about halfway between 0. Well, it is halfway between 0 and 90. What was the value at tangent at 45? 1. So I've got another dot at 1. At 60, what was tangent? Root 3. So root 3 is approximately, for those of you that don't know, it's 1.73. So there we go. So we got some dots there. We just don't know what's going on to the left. So let's go ahead and look from pi over 2 to 3 pi over 2. So let's start. What's the angle right after 90? 120? What's tangent at 120? Negative root 3. Oh, Oh, so that means that goes down here, so about negative 1.7. Okay. What about at 135? What is it at 135? What was the tangent at 135? Negative 1. Okay. What's the tangent at pi? Let's go to tangent of 180. We don't need the other one. We can kind of get the distance. 0. What do you think is going to happen between pi and 3 pi over 2? What's it going to look like? It's going to look like this interval. Okay, so that means it's going to have a dot pi right here, then a dot like right here, a dot like right here. So what tangent looks like if I connect these dots? It's going to look like this. And that's why the period is pi. It's just a bunch of these orange curves repeated. So over here we wondered what happened on the left. Well, this is what happens on the left. Okay, and then the graph's going to do this. So that's what the graph of tangent looks like. Your asymptotes are going to occur at where tangent is undefined. And if you forget, you've got your blue sheet to look at that. So pretty straightforward, right? Okay, so now we're going to look at what does negative tangent. So just for kicks, what do you think negative tangent's going to do? Because we don't even really need you to write out this too much. What do you think it's going to do?
The opposite.
Well, what do you mean when you say the opposite?
Flip it around.
It's going to go, what?
Go down.
What do you mean down? Reflect, okay, so I need some more.
Like it's gonna start up top and work its way down.
So it's going to do start up top and go down. It's going to start up top and go down. So that's what the negative does. The negative just causes it. And that should make sense because basically what you're doing is you're negating all of these values. So like when it was positive 0.5 through 7 or whatever, it's going to be negative 0.57. Okay, so that's what the negative tangent is going to look like. Okay, so tangent graph, we already looked at this. This is what it looks like. This is just a computer-generated drawing of what tangent looks like. It just keeps repeating over and over again. Okay, cotangent. All right, cotangent. You all have your blue sheet. So we're going to start with where the function is undefined. Where's the function undefined? 0. And where else? Pi. Anywhere else? 2 pi. Yep. Because 0 and 2 pi are essentially the same thing. Okay, so we'll throw another one right here. And we'll throw another one right here. And I'm going to have to draw that one a little closer to, and I'll move it in. Okay. There, we'll put it right there. So this was at pi and 2 pi. So where was the graph 0? Yep, 90, pi over 2, good. And where else? Yep, 3 pi over 2. Now we just got to figure out. Okay, we obviously know this is real similar to tangent. Okay, but we got to figure out how do these little curves go. Do they start high and go low? Or do they start low and go high? So this is what we do. We're just going to arbitrarily pick a value between 0 and 90. So we could pick 45. Okay, at 45, what is cotangent's value? 1. So that's going to put it up here. So let's just check, just to make sure. Let's pick a value between 90 and 180, which would be what? Okay, 120, 135. If we go with 135, what was 135 going to be? Negative 1. So how's the graph going to go? Yeah, so it's going to start high and go low. Because remember, tangent and cotangent are buddies, they're partners. So as a result, they're going to be real similar in a lot of their characteristics. So there you go. Now, how many periods have I graphed right there? 2. Okay, each one of those is a period. Okay, now we have 2 more graphs. Okay, there's what cotangent looks like. We already looked at that. We have secant. Now, before you get totally concerned about this, I want you to look and tell me what the blue graph is. The blue graph is what graph? Cosine, because it starts at a high point, right? So basically, the blue graph is cosine, and we know that cosine and secant are buddies. Okay, so the green graph is actually the secant graph. So just disregard the blue, and I could even, if it's really concerning you, I could do this. Okay, and so this is what the secant graph looks like. Now, real quick, I want you to tell me what's the lowest part on the upper U's. What's the lowest value on the upper U's? 1, right here. What's the highest value on the lower U's? -1. So you remember how we said cosine was always between -1 and +1? Secant is never between those values. It's actually less than -1 and bigger than 1. So this is what secant looks like. For kicks, what's the period in this one? Two pi, you should look in your notes. We wrote it down on the very first slide. Okay, and we wrote that's 2 pi. And the reason why it's 2 pi is because this hump doesn't repeat again till all the way over here. So a whole period is here. This is one part of it, and this is the other part of it. Okay, so now these are asymptotes too, so it's important that you get those down. These are asymptotes right here. Okay, where do those asymptotes occur? Pi over 2 and 3 pi over 2. Once again, if you didn't know where they occur, look at your blue sheet. Secant is undefined at 90 and 270. So that's what secant looks like. And those are like arrows on the end too. These should be like arrows here. So if I wanted to graph 2 full periods, you're going to have 4 of these little U's. 2 above and 2 below. All right, so far so good? Next one, cosecant. Once again, is along the same lines as secant. What's the red graph the graph of? Red graph is the graph of? Sine. So let's go ahead and get rid of it, just so. And you can kind of see cosecant has a lot of the same characteristics secant does. It doesn't go below 1, and it never goes above -1. What's the only difference between that and secant? The asymptotes. Yep, where do the asymptotes occur? Yep, pi and what else? -pi, yep. And also it's 0. There's one that's not written in there. There's actually 0, but that's where your asymptotes are. Okay. Questions? Now, we are not going to deal with a lot of translations of tangent, cotangent, secant, and cosecant. We're just going to focus on knowing the basics of each of the graphs. Okay. So, I need you to be able to graph all 4. I need you to know the basics about those, where the asymptotes are, the shape of the graphs, you know, the fact that cosecant doesn't go above -1 and it doesn't go below 1. Okay, so I need you to know those things. And so your assignment then from this section, and yes, I want this on a separate sheet of paper. I know you probably already got many notes, that's fine. But I need you to graph tangent, secant, cotangent, and cosecant. I need you to identify the period in each, and I need you to make sure that you graph 2 full periods. And that is going to be your assignment for Monday.
So like we graph like this?
Yep.